Hi there, welcome back to part 2 of the series on the Nordmende Phonosuper. Exact model as yet unknown. What I do know is that this is an export model. As I suspected, it differs from the printed or the published schematics. I've used so far the schematic for the Phonosuper that I found on the web. I have found many similarities, but I also have found some differences. None of those differences are too significant, so it is enough for to use as a reference to have got this to the point where I have it so far. And what I have so far is actually quite a big step ahead from where I was the last time, as you can probably establish if you saw the first video. I started off by doing the normal stuff. The first stage was testing the output transformer to determine whether that was okay, and yes, it's confirmed that it is working. I will link, I'll put a link above for the little video where I show you the technique that I use to determine safely whether the transformer is operational or not. And the second step was doing a similar test or a test on the power transformer to determine whether that was working or not, and I will also link above to the video that I show you, where I show you the technique I use to test these safely without using high voltages. So the result of these two tests was to tell me that in principle the power transformer and the output transformer are operational, and with that information we've really got a good basis to decide that this is a viable restoration. So then I moved on to the next step, which was to test the condition of the filter caps. This is a dual section filter cap, 100 microfarads and 50 microfarads at 350 to 385 volts. And what I found was that the values are slightly low. The leakage was within the expected norms. So what I decided to do is I tried to reform these, and for that I've shown a capacitor leakage tester and reformer, and I'll link that project above as well, which I used. And here it is. I used this to test the leakage, which I found to be within the expected range, and then reformed it overnight, probably 10 hours or so, and got it down to really low levels, which I believe will work well. So I think this capacitor has been successfully reformed, but we'll only know for certain when we switch it on and see if this thing's got any hum or not. So having completed those 3 stages, I then decided to get this thing ready to power on, and I started tracing the circuit from the power supply section, from the input rather, of the mains, checking for not the electrical connections, but checking for the wiring and continuity before powering this on, to make sure there were no dramatic shorts or anything like that in there. As you can see, there's a section of this board here that seems to have had a major facelift to it, and indeed it has. And the reason I've done all this before even powering this up, or trying to power this up, is I found something a little bit scary on the capacitors, which you normally expect, but this, in this particular case, I found one that was so off and so dangerously damaged that this thing could really have sparked if I'd applied power to it. And that led me to go one step further and check quite a few other components. And while I was there, you know, one thing leads to another, and you think, well, once you're there, you might as well do a bit more before actually risking putting power on this thing. And you'll see that various capacitors have been changed here. There's one there, there's one there, there's one there, there's that one there, there's this cathode bypass capacitor, there's a little one there. So this whole section here, which is on the power output stage, has been checked, and a lot of the connections to the power line, to the B+ line, has been checked. But I went through this for the purpose of getting this section, which is where most of the power flows, namely the output tube, safe before power on. And I know that's frustrating. I know it's frustrating for me because I want to hear this thing, but I have rushed it in the past and lived to regret it, because sometimes this thing can go up in some pretty nasty smoke and you do more damage than good. So I decided to take it easy and do this thing properly, because I'll show you what's happened with these capacitors. Again, using the leakage tester, and in this case it was purely as a leakage tester, these were the capacitors that are removed from those sections, and most of them are indeed not directly related to the power, except one or two. But this is what I found, and some of them don't look too dramatic, but you'll see why they actually are in a minute. There's a 0.1 that read 0.138, so it's 40% out. It had 140 microamps of leakage. Here's a 10N that read 17, so 70% out, 100 microamps of leakage. And this particular one was actually the one that coupled the preamplifier section, which has high voltage, the plate of the preamplifier tube, and coupled that to the grid of the EL84. So this thing, this 100 microamps, was flowing would flow into probably a 1 meg resistor. So you can work out what kind of bias adjustment, negative bias adjustment this thing would do. It's not good. So this thing was swapped out. These two are almost double. And the leakage is not that bad, but any leakage is bad, so these were swapped out as well. Here's a little guy of 100 picofarads that's reading 177, 22 microamps leakage. And then the main one is this guy here. This is the cathode bypass capacitor. It's 100 microfarads at 12 to 15 volts. This thing is at across the cathode resistor of the EL84, which sees a lot of current. That's where most of the current is. This is a single-ended amplifier, one tube, single-ended transformer. And so this thing really is to bypass AC. Well, it read 3.5 microfarads as opposed to 100, and it read over 65 ohms of internal resistance. So this thing had become a resistor rather than a capacitor. Now, the actual cathode resistor on this amp is, I think it's 180 ohms. So we basically put a 65 ohm resistor across 180 ohms. We basically got 40 ohms. So you can imagine what this is going to do to the bias of that tube. So I'm really glad I didn't switch this on with this capacitor in place. And that's one of the main ones that scared me. So what I have so far is, and I will show you that on the schematic, done quite a bit of the power stage, the power section, and also the power amplifier section. So part of the supply, part of the power amplifier section. I haven't done the preamp yet, but the most important one is the power supply. So I think we're in a position now just to switch it on carefully and see whether we're getting the voltages that we expect to get. I'm going to do this without tubes, obviously, but let's see where we go. So having prepared this, I've connected the meter ground to the negative of the meter to the chassis. That's 0 volts. I'm ready to measure DC volts over here, and I have connected a speaker because I don't want to switch this on without a speaker. That could do the output transformer some serious damage. And I have the lamp dimmer ready. It is active, it is off. I have 4 lamps on here. Only the 40-watt bulb is on, and I can then give it more bulbs to make the current limit less. So we'll start on the maximum limit. And what I'm going to do is I'm going to switch on the radio. The radio switches on with the power switch. There's a switch on the volume control. So there's a click. That's now on. I'll leave the volume low. And I'm going to put it on and just see what happens to that light bulb. Okay. Nothing. Nothing has come on. There's no current. I'm reading 237 volts, so there's no current, so this thing is not switching on. Oh, okay, all right, the switch didn't operate properly. Obviously there's some dirty contacts in the switch. I now have I've got 60 milliamps coming in there. Yeah, it's normal that it'd be very low current because there are no tubes. So what is this power driving? It's really driving the static circuitry, and there's no heaters, so there's no major current draw, and the dial lamp is on. So I'm going to leave it on a single light limit and we'll measure some voltages. As you can see here, the actual dial lamp over here is on, if you can see it in the video. Yep. And what I'm going to do is just get the meter in view, if I can do this without shorting anything out and killing myself. Okay, and down here I have a resistor. This one side is the B plus at the first filter capacitor. This resistor is the resistor that links the one filter capacitor to the other one, so you get B plus and B2 plus, say, right? So one of them should be higher than the other. It won't be very different because there's very little current draw. So we've got 333 volts, say, on that side, and 331.5 on that side. So that seems to be okay. Let's look at the EL84. Let's see. That's the anode, 332 volts. So we're getting voltage over there. That's pin 1, 2, 3, nothing. 4 and 5 are heaters. That is 7, 334. So one of these is the anode, one of them, what's that one? 0.9, that's 8, 333, 9. So one of them is the screen and one of them is the anode. In fact, that's the anode. I can hear some noise. Let's get some volume up here. I can hear some noise from the speaker. Okay, so we've got some action on there. There's B plus arriving at the EL84. If I check the preamp tubes, this preamp is an EBC81. I don't have off the top of my head the pinouts, but I'm just going to see if I find some high voltages on here. No, so far not. There we go, 319. Okay, so B plus is arriving here. So I'm getting some voltages. Let's look at the EF89. Just going pin 1, 2, 3, 4, 5 doesn't count because it's the heaters. Oh, we've got B plus there. We've got another one. So we've got high voltages on there. The ECH81, there's one there. So high voltage B plus is arriving at those points. I just want to check what the heater voltage is. Let's put that on AC. So 1, 2, 3, let's see, 4. That must be ground. 5, 6.6 volts. That's my heater voltage. So we're getting the heater voltages as well. We're getting B plus to these tubes, and I don't see any smoke, which is really promising. Now, I really am tempted just to actually power this up. Hope I don't regret it. Maybe I shouldn't, but anyway, let me think for a while. While I'm trying to decide on whether to actually power this up with tubes, do an actual power test, switch that off. Let's have a look quickly at this appendage that was stuck on the side, on the back rather, which I wasn't sure what the function was, and I think I've definitely figured it out. Some comments actually hit it on the head. This is a power amplifier, and it's a very interesting power amplifier because it is a mono push-pull power amplifier. And I presume what this was used for is to add stereo to your system. However, I don't really know where you'd get the signal from. because this has the two inputs, RCA jacks in there. It's two, I would presume that there's a stereo to mono a conversion inside here. This wire is still dangling somewhere, not sure where that's supposed to go to or where it comes from. Now, the one thing that's deceiving here, this cable here was connected to the antenna input of the radio. And as far as I can determine so far, this thing has absolutely nothing to do with RF. I may be wrong, but hey, give it some time. What I have found is that I've actually drawn up a schematic for this thing. And it's interesting in that it's actually quite a conventional. You've got a conventional power supply. The power coming in is shared with the power going to the turntable record player. Comes in, there's the bridge rectifier. The filter cap has two sections. There's a B plus and a B2 plus. And then those go to the transformer, and it goes to the center winding of the transformer, which is what you'd expect with a push-pull. That's the B plus. The other one goes to the screen grids of this tube, which is one tube. It's that one tube, which I thought could have been an EL84, but it's not. It's actually an ELL80. It's a dual pentode tube used in quite a few of these radios for push-pull function. My BRAUN Atelier 3, which I'll link above as well if you want to look at that project, actually uses two of these, one per side because it's stereo. And what this is two pentodes. I believe the equivalent for each is an EL91 or something like that. You can actually replace this dual tube with two separate ones if you can't find them. They are pretty rare and they're pretty expensive. I'm not sure if this one's working, but there's no marking on the tube itself. So I can't determine this from looking at the tube because it really is just black. Well, it's been scratched out. There's a bit of marking there, but I can't read it. But this is exactly what an ELL80 looks like, and I can only presume it is because the pinouts work. And I found that this B plus, the B2 plus, goes to these two pins, 1 and 9, which are the two screen grids of an ELL80. The actual transformer, each side of that transformer, goes to these two pins, which are, if I look at the rough notes over here, where is it? Pin 3 and pin 8. Pin 3 and pin 8. Those are the anodes of an ELL80. The 7 is a common cathode, which then is connected to the third screen over there. And then the grids of these two each have a capacitor, which I haven't drawn in yet. But they each have a capacitor. Actually, this is the original drawing. There's a resistor here. These are grid stopper resistors of 47K, and I've measured them. They're more or less okay. Then there's a 1 meg to ground in each case, and then there are two 47 nanofarad capacitors. Now this would seem to be exactly what you'd expect in a push-pull power output section. I haven't gone further with the tracing, but I will do that probably near the end of the series because I am absolutely, hell, never say that, I'm pretty certain this is simply a audio power amp. And I'm not sure that this thing would actually have any function in this particular radio because you would have no place to take that audio from. The output of this thing, it doesn't have a preamp audio which you'd need to plug into this. You would, if you wanted stereo, how would you get stereo? You don't have a separation in there for stereo. The phono comes in as mono. If the phono comes in as mono, which is what the phono connector allows for, you would then have a speaker output, which you could tap off to another speaker, but you really wouldn't have any stereo separation. So this thing is actually probably tacked in there. It's strange that the body of the radio lends itself to plug this in at the back because it actually has a cavity, unlike the other radios. The back end has a cavity where this thing fits in. This thing does cover some of the inputs. For example, the antenna inputs are behind this when this is in the chassis, which is why the temptation to plug this thing in was there. These two sockets go straight into the inputs. It seems to go into the input section. It goes one to ground, and the other one goes into this back here, which has three pots, which seem to be, I would imagine, volume, treble, and bass. I'll do the rest of the circuitry. I just didn't want to waste too much time on this so far, but that's what it looks like. This thing looks like an audio amp, push-pull, single stage, single channel. So I'm going to put that aside for now and come back to that later. This thing was obviously, or seems to be obviously, connected wrong, going into the antenna. This would have no business going into the antenna. So I don't know. Your guess is as good as mine as to why this thing was stacked on the back. But yeah, it was anyway. So this radio is being restored without this appendage for now, and we'll decide on what to do with that later. I've decided to give it a shot testing this thing with power. And the first thing I'm going to do is just power it on. Switch is off. I'm going to put this on with one lamp only, so maximum limit. I've put the tubes in, as you can see. So let's see what happens. I think we're okay. And I don't think anything too dramatic can go wrong, but let's switch on the power with the switch on the radio itself and see what happens to that light bulb. Okay, that's a good sign. It's come on and dimmed again, and we've got 80 milliamps, so we don't have anything too dramatic. The current should increase as the heaters warm up. Put the volume up, see if we can hear anything. Yes, we've got audio. We've got something. Volume's on max. I'm going to put it on medium wave because that's got the ferrite antenna for medium wave, and see if we can get anything. It seems to be trying. Well, we have the audio working. It's drawing 110 milliamps now. Switch that off before something goes wrong. But we didn't have any smoke. And I think we may be on the right track here. So now we have determined that this power amp, power tube, and the preamp tube seem to be doing their job because we have audio. As for the IF amplifier and the IF transformers, the cans, and the actual mixer oscillator over here, well, don't really know. It sounds like radio static. I was only using the ferrite antenna, which is at the top here. So I should have picked something up. This could be completely deaf, which is not a problem. We can sort that out. The important thing is we don't seem to have any major drama in terms of shorts or blown components or anything like that. I don't want to leave it on for too long, because what I'm going to do next is I'm going to go back from this point and work backwards to the front end, change all the caps that need changing before we can really see what the reception is like, if it's receiving well, and what else we need to do to this. There's quite a lot of cap swapping to be done. There are these on the top end here which need to be done very carefully, because you're working on an old PCB, and my experience with these caps proved you have to be very careful, otherwise you actually tear out the copper tracks on the PCB. So I'll do all those. There are a lot of them on the underside as well. So yeah, there's quite a bit to be done here, and I just want to show you before we sign off for this video the progress on the actual schematic. So here's what we've got so far using that schematic I told you about, not the exact model but close enough. For example, in this particular one, the switch actually switches both the live and the neutral. So I did all the checking of that. Everything that's green has been checked. Here's the filter can, which was reformed and stays in place. The two sections, that first B plus comes in here, goes into the power transformer. It comes out of the power transformer here through, so this acts as a bit of a choke, through that 1K5 resistor, and it goes to the second filter can, which is fine, reformed. Then that first B plus that came into the power transformer goes up through the transformer to the anode of the EL84. That's been checked. This second B plus goes into the screen grid of the EL84. It then has these components which happen to be in the way, so I checked them and changed out this capacitor. That goes to the speaker. This B plus, the second B plus, carries on at the top here, goes across, and it comes across to this tube. I have checked these resistors and swapped out those capacitors because they were basically on the B plus high voltage level. And I also checked and swapped out these capacitors. This one over here is really the main coupling cap, the 10 nanofarad one, which is the dangerous one. That's been checked and replaced. I've checked these components along here. Some of these 470 picofarad caps were fine. They're polystyrene ones that very rarely go wrong. The schematic is not exactly the same as this one. For example, in this particular radio, this switch, this speech switch, comes before the tone control. This is a bass control. That one there is a treble control. But basically, it's pretty close. The values are practically the same and the configuration is pretty close. So that's what's been done in terms of checking so far. The next stage that I'm going to go to is take it from this pickup input over here, the PA input. You can see it's actually a mono input. This is the phono input. Take that all the way down and check the preamplifier circuit. Now, the preamplifier circuit is going to be slightly different to this one because I notice this tube is an EABC 80 and it has these, this would be the FM discriminator for this particular radio that we have the schematic for, and the one I have does not use it. The one I have uses a different tube here, which is the EBC 41, I believe it is. So this is going to be very, very different. And since we have audio, I have one major problem solved. I don't really have to necessarily track the circuit. I have to be more attentive to the values that the components show and test those component values. I'll swap out the caps, but in terms of resistors, I can follow what the components themselves are supposed to be and check if those are okay. You can read the values on those resistors quite easily, so it shouldn't be a problem. So when I come back with the next video, I should have at least the full power amp stage checked, and who knows, maybe even further back, because this particular radio, this schematic, has the preamp tube over here. It has the EF89 here, which this one also has. Now bear in mind that after this EF89, it's going to meet a selector here, which will determine whether the preamp receives a signal from the pickup, the phono, or from the radio side. So this section will be pretty similar. The ECH81 will be very similar, except it won't have this other section here, which is where the FM does its job. It'll only be the AM side. And on this radio we have medium wave, long wave and short wave, I believe. And in this case I have medium wave, no long wave, and I've got
4 shortwave bands. So the values here will be very, very different, but we should be able to follow the logic. All it's doing really is swapping in different parts to change the frequency of oscillation and tuning. So it shouldn't be too difficult. Once you've got one band of shortwave, to follow the logic to the next band or the next 3 bands isn't too difficult. Yeah, so that's it for now. I'm going to get on with it and report back when I have some more news. Thanks for watching, and if you like this stuff, please subscribe. Bye for now.